All right, let's look at a couple problems with solving quadratic equations by factoring. So we're going to start off with one that's basic. So this is one that we look at, we know right away, like, look, there's an x squared and an x term. There's no way we're going to be able to solve this by taking the square root, so we need some other strategy. We've seen before, though, that expressions that look like this can be factored. We can look for terms that multiply together to be -10 and add together to be 3 and come up with two factors of this expression. So in this case, two numbers that multiply together to be -10, add together to be 3, I come up with, let's see, -2 and 5. All right, so that gives us our two factors for this expression, x minus 2 and x plus 5. All right, so we've taken this expression up top and we're just converting it to an equivalent expression. And the reason we're doing it is because of something called the zero product property. All right, which says that if you have two numbers that you're multiplying together, like x minus 2 and x plus 5, and they multiply together to be 0, then you know one of them has to be 0. There's no way around that. So we're able to then split this up and find that we have either x minus 2 equals 0 or x plus 5 equals 0. And either of those equations, both of those equations can then just be solved. Add 2 to both sides and you get x equals 2. Subtract 5 from both sides and you get x equals -5. Okay? And again, those are both the solutions. You have two solutions to this equation. There's a 2 in the exponent up there. That means that at most there can be two solutions. And most of the problems that we'll run into will have two solutions. Some of them will only have one. Occasionally, it's possible for there to be 0, but not really by factoring. So you'll mostly see these two solutions. All right, so let's look at an example. If we already have a factored expression, this is still quadratic. There's two x's. If you multiply this through, you'd get an x squared expression. X squared plus 9x plus 14 equals 0. But because it equals 0, we're allowed to use that zero product property to split it up. So we know that either this x plus 2 has to be 0 or this x plus 7 has to be 0. So again, because they multiply to be 0, one of them or the other have to be 0. All right. So if x plus 2 is 0, then x must be -2. And if x plus 7 is 0, then x must be -7. Let's fix that. -7. All right, let's move on to the next one. All right, so again, same thing. As complicated as it might look, these are two numbers, 3x minus 6 and 7x plus 4, that when you multiply them together, get you 0. So we know that, again, one of them or the other one must be 0. And again, we're solving for both. They both work. They are both going to give us solutions that if you plug them back into this expression would get you 0 altogether. Okay, so in this case in the green, adding 6 to both sides to get 3x equals 6, dividing both sides by 3 to get x equals 2. On this other side, on this other solution to this other equation, we're going to subtract 4 from both sides to get 7x equals -4, and divide both sides by 7 to get x equals -4 over 7, -4/7. Right, again, those are our two solutions. We are finished. Both of those are the answer. If you plugged in 2 all the way through, 3 times 2 is 6, minus 6 equals 0. And even though 7 times 2 plus 4 isn't 0, because one of them is 0, they'll multiply together to be 0. And the same thing if you plugged in -4/7. You would get 0. All right, so let's look at one that's more challenging. Okay, so we look at this, and it doesn't appear to be significantly more difficult. And we might even look at that left-hand side and say, oh, hey, well, that's factorable. I mean, there's two numbers that do multiply together to be 12 and add together to be 7. We could say, wait a second. No, there's not. There's no numbers that multiply together to be 12 and add together to be 7. So we can't do that. We couldn't solve that problem. But even if we did, even if we were able to factor this expression, it wouldn't matter because the other side of the equation isn't 0. So even if we did have two factors here, the whole expression wouldn't equal 0. We couldn't use the zero product property. There's plenty of numbers that if you have two of them and multiply them together, they would equal 6. In fact, there's infinitely many of them. So we need, in order to employ this, we need to get this 6 to be over here on the other side. We need that right-hand side to equal 0 for this to work. So we're going to subtract 6 from both sides. And we get x squared plus 7x equals plus 6, because 12 minus 6 is 6, plus 6 equals 0. And we do have two numbers that multiply together to be 6 and add together to be 7, which is 6 and 1. So we get x plus 6, x plus 1 equals 0. And that gives us, again, either x plus 6 equals 0 or x plus 1 equals 0. So x equals -6 or x equals -1. And again, it can look really complicated, but as long as it comes down to an expression that's factorable on the left-hand side and 0 on the right-hand side, as long as we can make it look like that, we should be fine. So here, we really don't want this 2x squared over there. We want it together with that expression, with that term. We really don't want this plus 7x here. We want it together with that 12x. And we'd really rather have this -6 over here on the other side so that we're left with nothing on the right-hand side. So that's what we'll do. We'll move the 2x squared over by subtracting it. So we get x squared, 3x squared minus 2x squared. We have 12x, and we want to move that 7x to combine with it by subtracting that 7x away from the right-hand side. And 12 minus 7 gets us 5x. And again, this -6 we want gone. We want on the left-hand side, so we're going to add 6 to both sides. And we're left with 0 on the right-hand side. So again, this is factorable. X plus 3 times x plus 2 equals 0, which gives us, eventually after solving, x plus 3 equals 0 and x plus 2 equals 0 will give us that x equals -3, and x equals -2. All right, finally, two other cases. Just because one looks simple, just because an expression or an equation like this one looks simple doesn't mean it's factorable. All right, so there's no two numbers right here that will multiply together to be 5 and add together to be 4. It doesn't exist. So that's just not factorable. We can't use this strategy or the square root strategy. We must have some other way of solving. We must need some other way of solving it. Whereas this expression here looks really complicated, but actually is factorable. And we've looked at strategies in the past, factoring by grouping and using the box method, that would allow us to factor this. In fact, just like that, they factor as 3x minus 7 and 2x plus 5 equals 0, and we could solve those too. We already have solved problems like that. That said, this is not the strategy I'd recommend here. So we'd want something else, because that's kind of a pain. So we'll get back to that pretty soon when we look at solving by the quadratic formula or solving by completing the square.